art of injection molding requires skill and craftsmanship. Learning the art means learning how to produce acceptable parts without a high percentage of rejects.
There are several problem areas which can cause rejects during a production run or when a new mold is being tried out. Unless these problem areas are understood and controlled, defective parts will occur.
We'll look at common defects and see how they are caused. We'll explain how to recognize them and how to correct them by a systematic examination of major problem areas.
Let's begin by defining the problem areas. Machine failure is, of course, an area that will affect a production cycle. Heating bands can get tired and quit. Electrical connections can be loose or shorted out. Hydraulic systems can leak. Valves can wear or clog. Oil can overheat and break down. Toggle pins can wear. Feed systems can clog or work erratically. Water supply can vary due to rust or scale.
The second problem area can be in the mold. It can be worn or damaged. Ejection systems may not operate properly. The mold may not be set properly.
The third area from which problems may arise is in the materials you use. Here are some things to check. Be sure you have not only the correct type of material, but also the right grade. Be sure you have the specified amount of regrind along with virgin material in the blend. Check the quality of regrind for correct particle size with no fine plastic dust.
The fourth problem area to consider is the operational area. This has to do with your plant. High humidity in the plant can cause trouble. Even the temperature of the room affects molding. The power supply can affect molding too. The electric power supplied to the machine must be adequate and constant.
The fifth possible problem area could be with the operator. The operator's rhythm has a lot to do with how a machine performs. Opening the safety gate as soon as the mold opens and closing it without delay each and every time is very important.
We've covered the 5 major areas that can contribute to defective parts. These 5 areas are the machine itself, where faulty electrical, mechanical, or hydraulic systems can cause problems.
The mold, which can be worn, damaged, or may not be set properly.
The material, improper grade, type, or contaminants.
Your operational area could be a problem because of humidity, temperature, or fluctuating power.
The 5th area to investigate for trouble is the operator and his rhythm on the job.
Now let's look at specific defects. Learn how to recognize them and determine how to avoid or correct them. The first defect is flash on the part. Flash occurs when material escapes from the mold. Heavy flash is pretty obvious, as on this part. Flash can also be a fine ridge or fin around the part, as on this cup.
When flash appears, the first place to look for the cause is in the machine. Check the clamp. Loose clamps can cause flash. The remedy is to increase the clamping pressure. Another cause of flashing can be that injection pressure is too high. Try decreasing it.
Maybe the pressure's right, but has been on too long. Here you cut booster time. Then check injection speed. Try lowering it.
Another cause of flashing can be melt temperature that is too high. Reduce melt temperature heats, starting at the nozzle and working back to the rear.
Check the screw controls and change back pressure, rotating speed, and torque.
Watch the feed for regularity. If it varies, it will cause surging. This will affect flow and may cause flash. Adjust for an even feed.
Another major problem area to check when flash occurs is the mold. If the mold's too hot, the plastic will be kept at too high a temperature for too long and can escape. Inspect the mold for damage, for wear, and for improper installation.
The material itself can be the reason for flash. You may have the wrong grade in the hopper. The amount and particle size of regrind affects the cycle. Small particles and fines heat faster than coarse pieces.
If you still haven't found the cause of your flash, check for any changes in room temperature. If it's high, it can affect oil temperature, mold temperature, the heating cylinder, or the hopper.
Operator's rhythm is very important in avoiding flash. A delay in opening or closing the safety gate increases melt temperature. As a result, injection will be too fast.
Now let's review these points. Flash is caused when plastic escapes from the mold. The causes for this can be a loose clamp, injection pressure that is too high, injection pressure being kept on too long, too fast an injection, too high a melt temperature, improper feed rate, damaged or overheated mold, using incorrect material, variable environmental conditions, operator negligence.
Flashing is just one of the defects we'll investigate. Before going on to others, these words of warning. Be patient. Run 10 shots with each single change you make before making other adjustments. With this in mind, please refer to your notebooks for further instructions. Please turn off the projector.
The last area we covered was the problem of flashing and some of the ways of correcting the situation. This information will be of use to us as we investigate the problem of parts sticking in the mold. There are several possible causes for parts sticking in the mold. One of these causes is too much plastic in each shot. We call it packing the cavity. Remember the term. We'll be using it several times. It can be a problem and sometimes a solution to problems. Some of these same corrections you make for flash can help solve the packing problem. Let's recap what they are. Reduce injection pressure. Reduce booster time to cut high pressure off sooner. Reduce injection speed. Lower the melt temperature. Reduce the feed, if possible, on a screw machine. Cool the mold more. Establish an operator rhythm.
All of these areas must be investigated carefully and patiently, one at a time, in order to correct for packing. But there are other reasons for parts sticking in the mold, and other solutions which might be used. If parts are sticking on the movable or ejector side of the mold, check for faulty ejection plate travel.
Also check for broken ejector pins or worn pins that create flash, causing the part to stick to the mold.
Sticking could also be caused by a poorly polished mold. If the cause is a broken ejector pin or damaged mold, replacement or repair will be necessary.
The next defect we'll discuss is a burn mark. Here are several parts that have burn marks. Burn marks are caused by air trapped in the mold when it closes. Air must be allowed to escape as the plastic fills the cavity. Air that doesn't get out gets compressed by the hot flowing plastic. The compression heats the air and burns the plastic. Many molds are vented so that air can escape. These vents are machined from the cavity edge to the edge of the mold or along the ejector pins. Check that these vents are not clogged with dirt or plastic. Another possible cause of burn marks is a mold clamped too tightly. Loosen the clamp slightly, but be careful not to loosen it to the point where you'll cause flashing.
You may also correct for burn marks by slowing the rate of injection. You can do this by lowering the injection speed, or by lowering the injection pressure, or by lowering booster time. Another solution to burn marks may be to reduce the flow by reducing the melt temperature. Another possible solution is to slow the fill rate by cooling the mold. Also, check the operator's rhythm. If he's delaying the cycle, he could be overheating the material.
Let's review these last two defects and possible causes. First, the part sticking in the mold. The possible causes are packing the mold with too much plastic, faulty ejection plate travel, broken ejector pins, a damaged mold, a poorly polished mold.
Next, we looked at burn marks. Burn marks are caused by air trapped in the mold by hot onrushing plastic. The compressed air becomes so hot it burns the plastic. Air must be allowed to escape from the mold. Now, please check your notebooks for instructions and turn off the projector.
The next defect we will examine is a short shot. Shorts are caused by failure to fill a cavity completely. Here are various degrees of unfilled parts.
There are many causes for short shots. Therefore, there are many possible corrections to consider. We'll list some of them, but don't try to memorize them. Just try to understand them. Raise injection pressure.
Increase injection speed.
Increase booster time.
Increase injection time.
Increase melt temperature.
Check your hopper. It may be empty or clogged.
Increase the feed.
Check the material. You may have the wrong one or the wrong amount of regrind.
Increase mold temperature.
Check the nozzle. It could be too small or damaged.
Be sure the nozzle seats correctly and is held tight against the sprue bushing. Again, rhythm is important. If the operator jumps the gate, that is, opens the safety gate before the cycle ends, he's cheating the plastic in the heating cylinder out of some of its required heating time, and it won't flow as well. These have been the causes of short shots and some solutions to them. Now let's look at some rules that hold hard and fast no matter what the problems are.
Proceed patiently. Make only one change at a time and run 10 shots before making another correction.
Proceed carefully. Make your corrections by small stages.
Be methodical. Keep records of the changes so that anyone can understand what you've already done in case you go on to some other area and someone else has to pick up on the problem.
Be constantly aware any adjustment you make to correct one defect may cause a defect of another kind.
We said in the beginning that injection molding is an art, but it's based on scientific principles of melting, flowing, and cooling. A plastic responds or flows according to its melt temperature. When it's relatively cold, it flows slower, and vice versa.
We've shown that there are 5 potential problem areas. Those areas are the machine, the mold, the material, operational conditions, the operator himself.
In our next film, we'll discuss these same areas and how they affect other kinds of defects. We'll also state 7 basic rules to follow as you make changes to avoid or correct defects.